We're now going to discuss some more quadric surfaces and methods to use for graphing them. The first thing that we need to discuss, though, is the definition of a trace curve. A trace curve is a curve of intersection between the surface and a plane parallel to a coordinate plane. So just a quick image to kind of demonstrate what a trace curve might look like. If we have a surface, any surface, I'm going to draw a sphere. A trace curve would be a curve of intersection between this surface, so an intersection curve between our sphere and a plane that is parallel to a coordinate plane. So I'm going to choose a plane that's parallel to the XZ plane. So let's graph a plane of intersection here. The trace curve would be the intersection curve between that sphere and the plane. So where the plane intersects the sphere. Notice this trace curve is existing entirely inside that plane, so the trace curve is also a plane curve, but a plane curve is a trace curve when the intersecting plane is parallel to one of the coordinate planes. So just to offer contrast here, if we had a plane that was intersecting our sphere where the plane was not parallel to one of the coordinate planes, we would get an intersection curve between the plane and the sphere, but this intersection curve would be a plane curve because it exists entirely in a plane, but it would not be a trace curve. Let's look at the case of the quadric surface, ax squared plus by squared plus cz squared is equal to d, and we'll assume that all a, b, and c and d have the same sign, all positive or all negative. Now, if a, b, and c are equal to each other, this is the case where we have a sphere. So the equation 2x squared plus 2y squared plus 2z squared would be a sphere. In order to write an equation that is an ellipsoid, again, we would need to have all of those having the same sign, but even if only one of the coefficients is not the same as the other two, that would now kick it out of sphere land, and we would end up with, in this case, an ellipsoid. Now, let's use trace curves to help us identify and graph this three-dimensional quadric surface. Now, in order to do that, we're going to graph some trace curves that are parallel to the XZ plane, to the XY plane, and to the YZ plane. So a trace curve that's parallel to one of these planes, for the XZ plane, this would be a curve that is contained in a plane where y is equal to some constant value. So let's start with letting y be equal to 0. The y equals to 0 plane is the XZ plane, and so we can see what this trace curve in the XZ plane is simply by plugging in y is equal to 0 in the equation. So let's do that. Setting y equal to 0, we get the equation 3x squared plus z squared is equal to 9, and in our xz plane, and let's graph that here like a two-dimensional plane, so this would be our xz plane. We'll take this over into 3 dimensions in a moment, but first of all, in our xz plane, we see that this is going to be an ellipse. Now remember, to graph an ellipse, the standard equation of an ellipse would be where we have this equal to 1, so we're going to divide both sides by 9 here to get x squared over 3 plus z squared over 9 is equal to 1. So our center is going to be at 0, 0, x 0, z is 0. I'm going to travel square root of 3 in the direction of x, and then 3 in the direction of z. So square root of 3 is 1.7 something, so let's just put our dot in between 1 and 2 here. We'll call this rad 3 as the x-coordinate and 0 as the z-coordinate, negative rad 3, 0 over here on the other side, and then 3 in the direction of z, we're going to get an ordered pair up here that is 0, 3, and then down here as being 0, negative 3. So we have a trace curve that exists in the xz plane that is an ellipse in this orientation. So let's do this again, but this time with a plane that is parallel to the xy plane. The xy plane itself is z is equal to 0. A plane parallel to the xy plane would be any plane that has z equaling to some constant value. But let's go ahead and graph the trace curve in the xy plane. Since z is equal to 0 is the xy plane, we can get the trace curve in the xy plane by plugging z is equal to 0 into our equation. When we do that, we see we have 3x squared plus 3y squared is equal to 9, and we can now tell that this is actually going to be a circle. We can use the same technique for graphing an ellipse to graph this circle, which is going to be to divide everything by 9. We'll end up with x squared over 3 plus y squared over 3 is equal to 1. So in the xy plane, we're going to be traveling the square root of 3 in the direction of x and in the direction of y. Of course, our center is still at 0, 0. Rad 3 is a little bit more than 1, a little bit less than 2. So we'll put our dot in between 1 and 2, and this is going to be the square root of 3 in the direction of x. And as well, we'll do square root of 3 in the direction of y. And then connect the dots to graph the trace curve in the xy plane. Before we do the last one, let's go ahead and graph these trace curves in those planes in our three-dimensional coordinate system. So in the xy plane, we had a circle. We had the ordered triples where we were traveling square root of 3 in each of these directions. So this point is going to be 0, square root 3 in the direction of y, and then 0 in the direction of z, so that's 0, rad 3, 0. Back here, we'll have 0 in the direction of x, negative rad 3 in the direction of y, and 0 in the direction of z. Because we are in the xz plane, notice that z coordinate is 0. So here in the direction of x, we're going to have rad 3, my y coordinate is 0, my z coordinate is 0, and then back here, we'll have negative rad 3 as the x coordinate, y is 0, z is 0, and that trace curve, as we mentioned, is a circle in the xz plane. We're going to have to try to graph it with some perspective here. Okay, so that's not too bad. In the xz plane, we saw that we had a ellipse that was elongated in the direction of z. We had an ordered triple that was going to be 0 for x, 0 for y, and 3 for z, but as well we have down here 0, 0, negative 3. And then in the direction of x, we still had these same two ordered pairs, right? We had this ordered pair and this ordered pair that were on that ellipse as well. So let's graph that ellipse in the xz plane. And we see that our ellipsoid is starting to take shape. So let's get one more trace curve, and this time we'll look at the trace curve in the YZ plane. A trace curve parallel to the YZ plane is going to be one that holds x constant. The equation x is equal to 0 is the YZ plane itself, and x is equal to a constant would be a plane parallel to the YZ plane. So let's see what that trace curve is in the YZ plane, and in order to do that, we simply plug x is equal to 0 into our equation. When we do, we get 3y squared plus z squared is equal to 9, and this is the two-dimensional trace curve in the YZ plane. Again, it's an ellipse, so we're going to divide both sides by 9 to get the standard form of the equation of an ellipse. We have y squared over 3 plus, that's supposed to be z squared, over 9 is equal to 1, and then that tells us that we're traveling rad 3 in the direction of y and 3 in the direction of z. So here we go. We already actually have these ordered pairs in the YZ plane. 3 in the direction of z, rad 3 in the direction of y, and now all we really need to do is connect those ordered triples to complete this ellipsoid. We'll now take this into GeoGebra to check our answer here. We're going to input the equation of our quadric surface, which was 3x squared plus 3y squared plus z squared is equal to 9. And as you can see, we do have an ellipsoid where the vertices are up at 0, 0, 3, 0, 0, negative 3. It also looks like our vertices are going to be hitting in between 1 and 2, which square root of 3 is at about 1.7. So that does look to be correct. Let's take a look, though, at our intersections with the plane curves. Notice x is equal to 0 is that YZ plane, and if we look to that YZ plane, we can see that we are getting an intersection curve that is an ellipse. If we then take a look at the plane y is equal to 0, notice y is equal to 0 is the xz plane, and in the xz plane we also get that ellipse that is going to have vertices at 0, 3 and radical 3, 0. Notice z is equal to 0 is the xy plane, and when we look at the intersection of the xy plane with our ellipse, we do get that circle that we had when we drew it by hand. So we can graph the trace curves in different planes and then put all of those trace curves together in the 3D coordinate system to help us get the graph of the surface and then check our answers using GeoGebra.